Assalamualaikum and hi, my name is Annisa Farahin binti FAUZI. In transport principal process, I am in LO1P2 and today I will try to solve the case study of this question. So, the case study is acetone is being absorbed by water in a packed tower having a cross-sectional area of 0.186 meter square of 293 K and 101.32 kilopascal, which is 1 atm. The inlet air contains 2.6 mole percent acetone and outlet 0.5%. The gas flow is 13.65 kg mole inlet air per hour. The pure water inlet flow is 45.36 kg mole water per hour. Firm coefficients for the given flows in the tower are K prime YA equals to 3.78 times 10 power of negative 2 kg mole per S dot M cube dot mole fraction, and K prime XA equals to 6.16 times 10 power of negative 2 kg mole per S dot M cube dot mole fraction. The K prime YA and the K prime XA represents the single mass transfer coefficients. Okay, gradient for the equilibrium line is 1.186, which is dm. So, question A, calculate the tower height using K prime YA. B, calculate the tower height using K prime XA, and C, calculate the tower height using K prime YA. Alright, so let's move on to the calculation. So, the given info is surface area, which is 0.186 meter square, temperature 293 Kelvin, pressure 101.32 kilopascal. The gradient for the equilibrium line, which is 1.186, and single mass transfer coefficients for gas and also liquid. Okay, for the gas is 3.78 times 10 power of negative 2, and for liquid is 6.16 times 10 power of negative 2. Alright, so this is how the packed tower looks like. There are gas inlet and gas outlet, absorbent inlet and also absorbent outlet. Okay, so in the question we have given the mole fraction for the gas inlet and the gas outlet, which is 0.026 and 0.005, and also the x1 and for the L2 and also V1 is given in the question. Alright, so the first thing first that we need to find is the operating line. So we have the X2 and Y2, but for the point 1 we only have Y1 but not X1. So to find the X1, we can use the equation in the appendix right here and just substitute the value in the equations. So x1 you will get 0.006478. By that you will have 2 points for the operating line, P1 and P2. So in the graph, just plot the 2 points here. Point 1 is here and the point 2 is here, and you will get a straight line. Okay, next, equilibrium line. For the equilibrium line, we already have the gradient, which is 1.186, and now we just need to substitute the value of y and x in the equation, which is y equals to mx. So the first x is 0, so you will get the y also 0. But for the second x, you will put any value that you want and you will get the y value. Just like I do, I put 0.02 as the x, and I will get 0.02372 for the y by using the formula y equals to mx. Okay, for the equilibrium line, I will also get a straight line by in the same graph paper. Okay, so you will have two lines, operating line and also equilibrium line here. Okay. Alright, so next, slope. We have two trials of slope, which are first trial and also second trial. For the first trial, we will try to plot the graph and find the value in the graph. But for the second trial, we will find the value by using the equations. So it will occupy the theoretical lesson. Okay, so for the first trial of slope, and this is for the point 1, you will get this equation in the appendix, and you will just substitute the value in it, and the gradient you will get negative 1.5976. To be easier, negative 1.6. Okay, so to find the intersection of the y-axis, you will need to use this equation, y equals to mx plus c. And now you will just need to substitute the value of y, m and x in the equation, and you will get the c value. The c value is 0.03635. Okay, so based on the plot graph, so how do we find the xi1, yi1 and y1 star? So in the graph, okay, so this is your operating line, this is your operating line, this is your equilibrium line. So and this is your first slope for the first point. Okay, so as you can see, there are intersection between slope 1 and also equilibrium line here. Okay, so from here you will just need to drag the point to the x-axis and to the y-axis, and that's it. You will get your xi1 and yi1. What about y1 star? For y1 star, you just need to drag the point from the intersection of operating line and the slope 1 to the equilibrium line and drag to the y-axis, and just like that you will get y1 star. Okay. Alright, so next is slope for the second trial. For the second trial, you will just need to take the equation from the appendix. This is the first equation, the second equation, and third equation. The first and second equation you will be needed to use in the third equation. You need to substitute the first and the second equation in the third equation. Alright, and just like that you will get the gradient, the m, which is negative 1.612. And now what we need to do is to compare between the first trial and the second trial. So the first trial we got negative 1.5976. or negative 1.6. And for the second trial, we got negative 1.612, which is also negative 1.6. So the first trial and the second trial is the same. So it shows that they are accurate. Okay. So for the point 2 of slope, we still use y equals to mx plus c and the same gradient, but now we will try to substitute the y value and the x value of the point 2 from here. This is the x value and this is the y value of point 2, and you will get the y-intercept is 0.005. To make it align, we need to have 2 points. So to find another point, we try to substitute y equals to 0, so that we will get the x value. So the x value, you will get 0.003125. And again, you will need to draw the second slope. This is the first point and this is the second point, and you will just need to draw the line. And to be a reminder, slope 1 and slope 2 will have a same gradient like this. Okay. Alright. Okay, next. Okay. So when we have the second slope, we can again find the x I2 and also y I2 and y2 star. Just like before, this is the second slope. So the slope and the equilibrium line, the intersection of them is the x I2 and y I2, while for the y2 star is when you drag down the point from the slope to the equilibrium line, and it is 0. Okay. Okay, next we need to find the height of tower. But to find the height of tower, we need to use various equations. So we need to use these equations before we find the height of the tank. Okay, so this is the first equation. Y minus YIM, you will get 0.00616. For the xi minus xm, you will get 0.00371. And for the v1 and v2, you will get 0.00389 and 0.00381. For the average of the v, you will get 0.00385. Okay. For the L prime, L1, L2 and L average has the same value, which are 0.0126 kilogram mole per second. And now we can calculate the height of tower. For K prime YA, which is the single mass transfer coefficient for gas, you will get the height is 1.8668 meter, and for the liquid coefficient, you will get 1.92 meter. Okay, but for the overall mass transfer coefficient, you will need to use this equation, and before we use this equation, you need to find this first, 1 minus y star m, to be substituted in the equation 1. Okay, so after we substitute the values, we will get the capital K prime YA is equal to 0.05. But to find the height, we need to use a different equation, which is this equation, equation 1 and equation 2 from the appendix. We need to substitute the equation 2 into the equation 1. Okay, and you will get, after we substitute, the height of the overall tank is 0.844 meter. Okay, so what more? I think that's all. For me. I hope you can understand, and yeah, I think that's all. Don't forget to subscribe and like the video. Bye.